Hi students, today we will discuss a concept and problems on adjoint of a matrices. Right. Now, coming to the adjoint, and we know that what is adjoint of a matrix is cofactors of a matrix whole transpose. Now, under this adjoint concept, we have some properties which was regularly asked in JEE mains. That's the most expected question in JEE mains. Okay, now to solve those questions, we need some formulas that I will discuss now. Here, to discuss about these properties, we want a square matrix. Let us consider a square matrix of order n. It is n by n. Then, the first property is adjoint of Ka, any constant which is multiplied by the matrix A is nothing but K power n minus 1 into adjoint A. Right. Now, for example, it is adjoint of Ka. Now, if we want adjoint of 2A, for suppose if A is a 3 by 3 matrix, if A is a 3 by 3 matrix, if we want adjoint of 2A. Now, what we can write, it is K power n minus 1. What is K here? 2. So, that 2 power n minus 1 is nothing but 2 into adjoint A. 2 square is 4. 4 times of adjoint A. That is the concept. Okay. Now, coming to the second formula. Right. What is the second formula? Determinant of adjoint A. What is the determinant of adjoint A? Det A whole power n minus 1, same as it is. Now the third one is det of adjoint A. So here, how many adjoints are there? Here is 2 adjoint of adjoint A. So that the formula is det A whole power n minus 1 whole square. For suppose in case of det of adjoint A, 3 adjoint are there, then the formula is det A whole power n minus 1 whole cube. If it is 4, then 4 adjoints, adjoint of one more adjoint A here, then we can write it as det A whole power n minus 1 whole power 4. Okay. Then, now move on to the next one. It's a multiplication, adjoint of AB, adjoint B into adjoint A. Next one, adjoint of adjoint A without the determinant, that is det A whole power n minus 2 into A, where n is order of the matrix. Now, the most important one is det of Ka, that is K power n into det A. For suppose the determinant of 2A, where A is a matrix of order 3, A is a square matrix of order 3, then we can write this one as 2 cube into det A, which is not 2 into det A. It is not 2 into det A. It is 2 cube into det A. For suppose if it is like 5 times of A, where A is a matrix of order having 2, then we can write this one as 5 square into det A. So this is the concept. Like this, the way we can solve this type of questions. Now coming to the next one, the very important one, which will be used in board exams also and KSET level type of exams also. The most important formula, that is det of A inverse, which is equal to 1 by det A. Det of A inverse, which is equal to 1 by det A. Right. These are the most important properties, and from these properties we will get one question in JEE mains exam. Okay. Now, based on these properties, I will solve some questions which will help you a lot to understand the concept of adjoint. Now, coming to the first question. Now, see the first question. Here, let A be a non-singular matrix of order 3. That is very important. A is a non-singular matrix of order 3. So clearly what he was conveying, A is a square matrix of order 3. Clearly here n equal to 3. Right. Now here n equal to 3, which is very very important, right? Now we need, what is the given condition is, he didn't mention about det A, but they given det of 3 times of adjoint A of 2 times of adjoint A of det A into A equal to 3 power minus 13 into 2 power minus 10. And the next condition also they given. From this we need to find modulus of 3m plus 2n value, right? Now coming to the first condition, here it is det of 3 times of adjoint of 2 times of adjoint of det A into A, right, which is equal to 3 power minus 13 into 2 power minus 10. And we have a condition over determinant of Ka. See, for suppose now I can consider this everything is nothing but the matrix A. Joint is also matrix, so that is nothing but A. So now I can use here that the concept is det of Ka, that is nothing but k power n into det A, right? So this is the concept now I have to use. Now coming to this, what is k here? 3 power n. What is n here? 3. So that is 3 cube det of adjoint of 2 times of adjoint of det A into A equal to 3 power minus 13 into 2 power minus 10. Now again here next concept, this is what determinant of adjoint A. Now determinant of adjoint A. What is determinant of adjoint A? Det A whole power, like here what we have to do, det of adjoint A, that is what det A whole power n minus 1. Now this formula we are going to use now. Now see this, so 3 cube det, what is A? 2 adjoint of det A into A whole power n minus 1. N is what? 3 whole square, that is equal to 3 power minus 13 into 2 power minus 10, right? Now we know that det of K is k power n into det A, k power n into det A. See, if you observe this, it is in the form of det of K, this is what I can say, that K, and this is nothing but A, det of Ka, k power n det A. From this k power n, what is k power n? 2 cube det adjoint of det A into A whole square equals to 3 power minus 13 into 2 power minus 10. Now 2 cube whole square, that is what? 2 power 6, correct? Then 3 cube into 2 power 6 into det of, this is what? Adjoint of, this is what? Det A into A, I can write, whole square equal to 3 power minus 13 into 2 power minus 10. No confusion. Now again we have a formula, that is adjoint of, here inside adjoint of Ka, because of det, if you observe, det is constant, it is not a matrix, it is a real number. Adjoint of Ka, what is meant by adjoint of Ka? Now I write the formula, adjoint of Ka equals to k power n minus 1 into adjoint A, right? Now this is what? 3 cube into 2 power 6 into det of adjoint of K, k power n minus 1 means det A whole power n minus 1, which is nothing but square, into adjoint A whole square, that is equal to 3 power minus 13 into 2 power minus 10. Okay, now from this, what is det of Ka? K power n into det A, right? See, clearly this is what k, this is what a. Clear? So from this is what 3 cube into 2 power 6 into, so k a, that of k a we can write as k power n, so which is nothing but k power n, that of a, again whole square, that is equal to 3 power minus 13 into 2 power minus 10. So this one, if you observe this one, that a whole square, 2 3s are 6, 6 2s are 12. So here 3 participation, 2 3s are 6, 6 3s are 12. So clearly 3 cube 2 power 6 that a whole square 4 power 12 into this one det of adjoint a. Now I'll write this one directly, det of adjoint a. Now see this. What about det of adjoint a? Det a whole power n minus 1, that is nothing but det a whole square. Here already whole square is there. This 2 I distributed for this and now I distributed for this. That is equal to 3 power minus 13 into 2 power minus 10. Okay, fine. Now det a whole power 12, det a whole power 4, that is what I can say that det a whole power 16 is equals to, this is what 3 power minus 16 into 2 power minus 16. Now if I send 3 cube right side, 3 power minus 3, 3 power minus 16. So that det a whole power 16 equal to 1 by 3 into 2 whole power 16, so that det a equal to 1 by 3 into 2, we can say that it is 1 by 6. We got det a value is 1 by 6. Now from this we have one more concept, det of 3 times of adjoint of 2a. Now coming to this, det of 3 times of adjoint 2a equals to what they given, 2 power m into 3 power n. Right. Now here we have a formula, that of k a, k power n, 3 power 3, det of adjoint 2a, that is equal to 2 power m 3 power n. Right. So that is 3 power 3 into det of adjoint of k a, k power n minus 1, means 2 power 3 minus 1 2 into, this is what adjoint a, is equal to 2 power m into 3 power n. Now it is what, det of k a, det of k a, k power n, 3 cube into 2 square whole cube into det of adjoint a equals to 2 power m 3 power n. So that there is 3 cube 2 power 6 into adjoint a, det of adjoint a, det a whole power n minus 1, that is what I can say that det a whole square, that is 2 power m into 3 power n, 3 cube into 2 power 6 into det a. What is det a here? 1 by 3 into 2, right? 1 by 6, I can say that 1 by 3 square into 2 square, that is 2 power m into 3 power n. Now here this will get cancelled and here it will get 4. So clearly it is what, 2 power 4 into 3 power 1 equal to 2 power m into 3 power n. Now if you compare both sides, m equal to 4 and n equal to 1. Now what we want finally, modulus of 3m plus 2n, that is equal to 3 4s are 12, 2 1s are 2, that is what is equal to 4. That is the correct answer. Now here it is a fill in the blanks question. Now the answer is what? 14. Right. Now move on to the second question. Here. In case of the second question, let a be a, see, now second question we will solve it later. Now see this one, it's a very similar to that, but here they didn't mention order. what they given is n only. Here we need to find the value of n only finally, but here they given det A. What is det A? 2. Let A be a n by n matrix such that det A equal to 2 if the determinant of the matrix adjoint of 2 times of adjoint of 2A inverse equal to 2 power 84. Okay, in case of that we need to find the value of n. Okay, fine. Now coming to the solution. So, yeah, what is the given? See, they given det A equal to 2 and the det of adjoint of 2 times of adjoint of 2A inverse equals to 2 power 84, right? Now we know that what is adjoint of A. Determinant of adjoint A is what? Det A whole power n minus 1. See here, what is A? This is nothing but A. Determinant of adjoint A. So det A in the sense 2 adjoint 2A inverse. This is everything is nothing but A here now. Whole power det A whole power n minus 1. Because we don't know what is n, I wrote n minus 1 directly. That is equal to 2 power 84. Now, so here it is in the form of det of k a. This is nothing but a, is k. So det of ka is nothing but what? K power n into det a. K power n. So that is what? 2 power n into det of adjoint of 2a inverse whole power n minus 1, that is equal to 2 power 84. Now 2 power n whole power n minus 1, which is nothing but 2 power n into n minus 1. Now det of adjoint A, again here det of adjoint A. What is meant by det of adjoint A? Det A whole power n minus 1. So here 2A inverse whole power n minus 1, already whole power n minus 1 is there, that is equal to 2 power 84, right? Then it is what? 2 power n into n minus 1 into clearly det of 2A inverse whole power n minus 1 whole square equals to 2 power 84, right? Now here if you observe clearly, it is in the form of determinant of ka, det ka, k power n into det a. So this is what? 2 power n into n minus 1, k power n. So 2 power n minus 1 whole square, k power n, right? K power n into det of A inverse whole power n minus 1 whole square equal to 2 power 84, right? So that is 2 power n into n minus 1 into 2 power n into n minus 1 whole square, a power m whole power m, into the last property what we discussed it, det of A inverse is nothing but 1 by det A. So that is 1 by det A whole power n minus 1 whole square, that is equal to 2 power 84, right? The det A value what we have is 2. I'll substitute 2 here. Det A is 2. So that it is 2 power n into n minus 1 plus n into n minus 1 whole square minus n minus 1 whole square, which is equal to 2 power 84. Now bases are equal, then you can equate the powers, and in the numerator I can take n minus 1 common, so that n plus n into n minus 1 minus of n minus 1, which is equal to 84. So that is n minus 1 into n plus n square minus n plus 1, which is equal to what? 84. Now minus n plus n gets cancelled. N minus 1 into n square minus n plus 1 equal to 84. They given, what is that? N is a order of the matrix, right? We need to find the value of n. We can't substitute n equal to 1, which will become 0 is the answer. 1 minus 1, 0. And 1 it is impossible. 2 minus 1, 2, 4 square. So 2 square is 4, 4 minus 2, that you won't get 84. 3, it is not possible. 4, let us consider that n equal to 5 for suppose. 5 minus 1 is 4 times of 5 square is what? 25 minus 4 plus 1. It is what? Minus 25 minus 4 21. Yeah, it's fine. So 25 minus 4, then which is nothing but 84. Correct. So n equal to 5 is the correct answer. Now the answer is 5. Now move on to the next question. See, very interesting question. That is, consider a matrix capital A, alpha, beta, gamma, alpha square, gamma square, beta plus gamma, alpha plus beta. And they given one more condition here, it is that of adjoint of adjoint of adjoint of adjoint A. 4 adjoints they given, and we know that how many adjoints, that many number of power we can write. Now see the matrix. From that matrix, if I take the determinant, det A is equal to det of, here we can say that alpha, beta, gamma, alpha square, beta square, gamma square. So now next is beta plus gamma, alpha plus gamma, and alpha plus beta. Now R1 gives R1 plus R3. If I do like this, then det A, which is equals to, this is what I can say that alpha plus beta plus gamma. Here also we can get alpha plus beta plus gamma. Here also we will get alpha plus beta plus gamma. And it is alpha square, beta square, gamma square. And this one is beta plus gamma, alpha plus gamma. And it is what? Alpha plus beta. Now, that's okay. Yeah. Row 3 gives row 3 minus row 1. The first value, alpha plus beta plus gamma, alpha plus beta plus gamma, alpha plus beta plus gamma, alpha square, beta square, gamma square. Here what will get? Minus alpha, minus beta, minus gamma. Right. See, if I take alpha plus beta plus gamma common from the first row, then here will get 1, 1, 1. If we exchange the second to third, like if we interchange those two, R2 to R3, then we will get sign, negative sign. So instead of putting the negative sign, that alpha minus beta minus gamma will convert to positive. So I can write this one is alpha, beta, gamma, and the third row alpha square, beta square, gamma square. Actually, if you interchange that, the second row we will get minus alpha, minus beta, minus gamma. When we interchange the two rows, which is not in the particular order, we have to write the minus again. We need to multiply with one more minus again. Minus of minus will become plus. So, and if you observe this, the determinant, it's a very standard determinant. This one, if you observe, this is the very standard determinant. 1, 1, 1, alpha, beta, gamma, alpha square, beta square, gamma square, which is nothing but alpha minus beta into beta minus gamma into alpha minus gamma minus alpha. Right. Now, coming to the question, what is the given? Det of 4 adjoints. 4 adjoints. And a matrix anyway 3 by 3. It is, if you observe that, it will clearly. 4 adjoints. So that what will be the numerator is det A whole power n minus 1 whole power 4. What is n? 4 adjoints, right? So that is what I can say, that det A whole power n minus 1 whole power 4. N is what? 3. 3 minus 1, 2. 2 power 4 is what? 16. Det A whole power 16. The numerator will become det A whole power 16. The numerator is nothing but det A whole power 16. See, det A whole power 16. What is that whole power 16 here? For this? That is alpha plus beta plus gamma whole power 16, alpha minus beta whole power 16, beta minus gamma whole power 16, gamma minus alpha whole power 16, divided by what we have, alpha minus beta whole power 16, beta minus gamma whole power 16 and gamma minus alpha whole power 16, which is equals to 2 power 32 into 3 power 16. See, this value both will get cancelled. We have alpha plus beta plus gamma whole power 16 equal to, here 2 square into 3 whole power 16 we can write. That is what 2 power 32, 2 square whole power 16. Now when you compare alpha plus beta plus gamma equal to 2 square is 4, 4 3 is 12. So alpha plus beta plus gamma equal to 12. Still the problem not completed. Now coming to the main part of the question, that is, here they given alpha, beta, gamma are three distinct natural numbers. Distinct natural numbers. So all alpha, beta, gamma should be different. So according to this, what he was conveying, that alpha which is not equal to beta, which is not equal to gamma. Correct? Then what he want? Number of such tuples. Number of such tuples. We want tuples, right? See, how can we get the tuple? If we observe clearly, alpha plus beta plus gamma equal to 12, right? In case of this, the one very important formula what we have in combinations, which is, and anyway they given alpha, beta, gamma are three distinct natural numbers. So the formula is, in case of it is number of tuples, in case of number of tuples, like triplets. So we can say that n minus 1 c r minus 1. That is what 12 minus 1 c 3 minus 1. In this total, if you observe clearly, in this total number of tuples, we have one combination, that is 4 comma 4 comma 4, which is also present. That will satisfy. Correct? 4 comma 4 comma 4, it will satisfy. That is the only one tuple, it's a triplet which is equal, that I have to eliminate because of alpha not equal to beta not equal to gamma. So this is 3 alpha, beta, gamma, 3 are equal, which is not possible according to the concept of the question. So that also I have to eliminate. And one more thing also I have to eliminate, because of from this total, in this total all should present. All 3 are equal, all 2 are also equal. That how many those 2 are equal are, I will tell you. See, coming to that, we can write 1, 1 and 10. Right? 2, 2, 8. We can write. Next one, 3, 3 is like 6 and one more 6. See, what I am trying to say is, here all the 3 not equal, right? Here 1, 1, this is also one possible tuple. Here this is one possible tuple, this is one possible tuple, and we can't write 4 comma 4 comma 4 because of that is a triplet which is all equal, already eliminated. So 4 4 4, no need to write. One more thing we can write, that is 5 5 2. It is possible. It is also possible. This also I have to eliminate. This also I have to eliminate. Correct? Then after this, can we write 6 6? If I write 6 6, the tuple and one more tuple we have to write, here it is 0, but 0 is not a natural number. So this type of this is anyway not possible. So here the possible things are only this 4. Correct? So then I can write as 4 such type of arrangements. Now coming to the selection part. Right, out of 3 I can select 2 equal. Right, now this is what 11c2 minus 1 minus 12. 11c2, 11 into 10 divided by 2, that is what 55 minus 13, which is nothing but 42. So the answer for this question is number of such tuples are 42. Coming to the next question. The positive value of determinant of the matrix A whose adjoint of adjoint A, they given adjoint of adjoint A, anyway that is a matrix, we want positive value of the determinant of the matrix A. Simply they want det A, which is positive value he wants. Now coming to the solution. Now I can take directly both sides det, that is adjoint of adjoint A, simply that is determinant of 14 28 minus 14 minus 14 14 28 28 minus 14 14, right? Now anyway two adjoints, the det of two adjoints participated, so that I can say that det A whole power n minus 1 whole square here, n minus 1 whole square. What is n here? It is a 3 by 3 matrix. So clearly here I can write as det A whole power n minus 1 whole square. 3 minus 1 2. 2 square is nothing but 4. From the first row I can take 14 common. From the second row also I can take 14 common. Third row also I can take 14 common. Now what is the final value? 1 2 minus 1 minus 1 1 2 2 minus 1 1. So that this is what det A whole power 14 equal to, that is what, 14 cube into. Now coming to this one, is what, 3 minus 2 into minus 5 minus 1 into minus 1, right? So that det A whole power 14 equal to 14 cube into 10, it's like 14. So det A whole power 14, sorry 4, det A whole power 4 equal to 14 power 4, then the positive value of the determinant here it is 14. So the answer is what? 14 here. Now here, coming to the second question. In the second question, see, before going to the second question, I want to give you one question which you have to solve here. See, this is the question. We can solve this question, sixth question, and you can comment the answer. Let A be a 3 by 3 real matrix if det of 2 times of adjoint of 2 times of adjoint 2A equal to 2 power 41, then the value of det of A square. Now you can solve this question by using the same concepts and comment your answer. Okay, now I will tell you one more question here, which is, print is not there, then I will write the question here again. See, what the question is. Now here it's anyway it is a square matrix. Okay, fine. Now here if you observe so many adjoints, that number of adjoints are 24 times are there. That many number of adjoints are there here. Okay, now the question is, let A be a 3 by 3 matrix. A be a 3 by 3 matrix. Yeah, question came. And det A equal to what? 2. Here det A is equals to 2. And what is n? Det of adjoint of 20 24 times. So clearly NA equal to det of here adjoint of and so on adjoint A, how many times? 20 24 times, right? So that n equals to, and what is n? Order of the matrix here is, n is not the order of the matrix. Order of the matrix is what? 3 by 3. Now we know that here det A whole power n minus 1 whole power 20 24, that is n minus 1 is 2 whole power 20 24. So that n equal to, det A is nothing but 2 power 2 whole power 20 24. else. Then, so from this I can write this one as n equal to, clearly there is 2 power 40 48. Now from this n I can write as, now anyway it is n, but then remainder when n is divided by 9. Now we want the remainder when n, if it is divided by 9, then we need to find the remainder, right? Now it's a very interesting question. Now from this I can separate 2 power 4, then it is what, 2 power 4044, because why I separated that one is, it's just 44 which is divided by 3, that is 2 power 4 into, then I can write this one as 2 cube whole power 1348. So that n equals to 2 power 4 into 8, we will get 1348, right? Then n equal to 2 power 4 8, I can write as 9 minus 1 whole power 1348. Now anyway, if you observe this one, it's a multiples of 9 every time except the last value, which is what, minus 1. Anyway power, even power, then I'll get then the total after expanding, it is a multiples of 9 except that one. Anyway minus 1 whole power 1348 will get the last term, because of it is an even, and then I can write it as plus, right? Then it is 16 into 9k plus 16 will get, then n equal to 9 times of 16k plus this one I can write as 9 plus 7. So that n equal to 9 times of 16k plus 1 plus 7. So that this n is completely divided by 9, and we have a remainder which is nothing but 7. What is the remainder here is what? 7. Okay, fine. Students, don't forget to solve the 6th question, which is a very important concept. Again I will read the question. Let A be a 3 by 3 real matrix if det of 2 times of adjoint of 2 times of adjoint 2A equal to 2 power 41, then the value of det is square. Okay, thank you.